Hello my dear friends, welcome to the all of you. Myself Dattu Patel, Assistant Professor from LJIT. Last session we are already discussed about the finding the particular integral, shortcut method or direct method to finding the particular integral. We have total 5 cases. Last session we discussed about the case 1. Today's session we are going to discuss about the case 2 when q of x equal to in terms of sin ax plus b or cos ax plus b to finding the particular integral. Then yp equal to 1 upon f of d sin ax plus b or cos ax plus b. At that case, this whatever the term in f of d in terms of d square, that is indicated by phi of d square, then at that case d square which is replaced as a minus a square. Suppose we have the term d raised to 4, then what we have to do? Convert in terms of d square, then d square whole square, then d square which is replaced as a minus a square whole square, then it becomes a raised to 4. Suppose we have the term d cube, then it is replaced as a d into d square, then d kept as it is, d square which is replaced as a minus a square, then it becomes minus a square into d. Whenever our function or our q of x which is in terms of sine or cos, but here little bit condition, here phi of minus a square not equal to 0, then we replace d square is equal to minus a square directly. But if it becomes 0, then what we have to do? According to the last method, multiply with x and derivative of that particular term, then x upon phi dash of minus a square sin ax plus b or cos ax plus b. But condition which is phi dash of minus a square not equal to 0. Suppose it is 0, then again repeating process, multiply with x means it's become x square 1 upon phi double dash of minus a square sin ax plus b or cos ax plus b. If phi double dash of minus a square which is not equal to 0, suppose it is 0, then again multiply with x and derivative of its term, repeating until here derivative term should not be 0. Understood? Let's move on the one example based on the shortcut cases. Here case 2. See the one example. Solve d square plus 3d plus 2 of y equal to sin 2x. Where we apply case 2 whenever our q of x which is in terms of sine as well as cosine function. Then what we have to do? Firstly, we find the complementary function, then after we find the particular integral, and general solution is nothing but the combination of complementary function and particular integral. See, auxiliary equation is equal to d square plus 3d plus 2 equal to 0. Now factorize that term, means 2 ones are d plus 2, d plus 1 equal to 0, then values of d equal to minus 1, minus 2, which is real and distinct, means we use case 1, real and non-repeated or a distinct, then we use case 1 of yc, then yc equal to complementary function is equal to c1 e raised to m1x, that is minus x, plus c2 e raised to m2x, that is minus 2x. Then yp equal to, we have the formula, yp equal to 1 upon f of d into q of x, substituting the values of f of d and q of x, then that particular term which is indicated by the f of d and is equal to, that is indicated by the q of x. Now substituting the values of f of d and q of x, that is 1 upon d square plus 3d plus 2 into sin 2x. Now at that case we replace d square equal to minus a square. See here minus a square, sometimes students occurs by minus a whole square, that is the little bit mistake. See here we replace minus a square, here values of a equal to 2, then replace d as a 2, then minus 2 square plus 3d plus 2 into sin 2x, then it becomes 3d minus 2 sin 2x. See here our denominator portion has a d term, but at that particular case we require the denominator portion has a d square. For that what we have to do? Obviously multiply and divide with opposite sign of denominator portion, that means apply the conjugate, means multiply and divide with 3d plus 2 into sin 2x. See here denominator portion has a minus b, a plus b, then it becomes a square minus b square, then denominator portion has a 9d square minus 4 into sin 2x and numerator portion has a 3d plus 2. See now here again replace as a d square equal to minus a square, then here values of a is equal to 2, then it becomes 9 kept as it is minus 2 square minus 4 sin 2x, here numerator portion has a 3d plus 2, then it becomes minus 40 whenever we simplify denominator portion. Now whenever our differential equation has a product form has a d, then we can written as a d by dx, and 1 upon d, then it becomes integral form, integral of function into dx, and 1 upon d, then we apply integration. In product form as a d, then we apply derivative. See here in terms of product form, then minus 3 by 40 kept as it is, d which is replaced as a d by dx or derivative, that is d indicated by the operator, then we can written as a d by dx as well as capital D sin 2x minus 2 by 40 sin 2x, here operator was not present, then which is kept as it is, here 2 2s are 20, understood, then minus 3 by 20 derivative of sin, that is cos 2x into 2, then 2 will be cancelled out, then it becomes minus 3 by 20 cos 2x minus 1 by 20 sin 2x. Now general solution is a y of x equal to combination of complementary function plus particular integral. Substituting the values of complementary function and particular integral, that will give you c1 e raised to minus x plus c2 e raised to minus 2x minus 3 by 20 cos 2x minus 1 by 20 sin 2x, where c1 and c2 are arbitrary constant. Let's move on. One more example. Solve the d square plus 9 of y is equal to cos 4x. See, firstly what we have to do, obviously auxiliary equation is m square plus 9 equal to 0, then m square equal to minus 9, then m is equal to plus or minus 3i, means here 0 plus or minus 3i, then factors are complex pairs, then we use case 3 of yc, then yc of x equal to, here values of a that is 0, then e raised to 0x c1 cos 3x plus c2 sin 3x, e raised to 0 1, then c1 cos 3x plus c2 sin 3x, that is our equation number 1. Now we have the formula yp is equal to 1 upon f of d into q of x. Now substituting the values of f of d, that term indicated by the f of d and this term indicated by the q of x, then d square plus 9 into cos 4x. See here values of a is equal to 4, then replace d square equal to minus a square, then 1 by minus 4 square, this one is square inside the bracket, means minus sign as it is 4 square plus 9 into cos 4x. Now that is minus 16 plus 9 cos 4x, then it becomes minus 16 plus 9, that is minus 7 cos 4x, understood, minus 16 plus 9, that is minus 7 cos 4x, that is the yp of x. Now general solution is y of x equal to combination of complementary function and particular integral. Here whenever we finding the factors, then it's become plus or minus 3i, then it's become c1 cos 3x plus c2 sin 3x minus 1 by 7 cos 4x, where c1 and c2 are arbitrary constant. Let's move on. One more example. Solve the d square plus 9 of y is equal to 2 sin 3x plus cos 3x. See in this example d square plus 9, then obviously above example m square plus 9 equal to 0, that is our auxiliary equation. Then m is equal to plus or minus 3i. Then yc is equal to c1 cos 3x plus c2 sin 3x. Now yp is equal to, we have the formula 1 upon f of d into q of x, then 1 upon f of d, that is d square plus 9, q of x, which is 2 sin 3x plus cos 3x. Now what we have to do? Just simplify that term, means 2 constant which is comes out, 1 upon d square plus 9 sin 3x plus 1 upon d square plus 9 into cos 3 according to the linearity property. Now here in first term values of a equal to 3, in second term values of a equal to 3, again first term in terms of sine, second term which is in terms of cos. At that case what we have to do? Replace d square equal to minus a square, then our term becomes 2 kept as it is, d square as a minus a square, then minus 9, then minus 9 plus 9, it becomes 0. Then what we have to do? Obviously multiply with x and derivative of denominator portion, that is 2d, derivative of 9, that is 0 into sin 3x. Similarly here again whenever we replace d square equal to minus square, that is minus 9 plus 9, it becomes 0, then multiply with x and derivative of f of d, that is f dash of d, that is 2d into cos 3x. See here 2 will be cancelled out, then x kept as it is, 1 upon d, it becomes integral 1 upon d, then integral sin 3x dx plus x by 2 kept as it is, 1 upon d, then integral cos 3x dx. Now integral of sine, that is minus cos, then x minus cos 3x by 3 plus x by 2, integral of cos, that is sin 3x by 3. Now simplify that terms, then our yp becomes yp of x equal to minus x by 3 cos 3x plus 1 by 6 x sin 3x. Now general solution is a nothing but the combination of complementary function and particular integral. Then substituting the values of complementary function, which is c1 cos 3x plus c2 sin 3x minus particular integral, which is minus x by 3 cos 3x plus 1 by 6 x sin 3x, where c1 and c2 are arbitrary constant. Let's move on. One more example. Solve the d square plus 6d plus 8 of y is equal to cos square x. See here our q of x equal to cos square x. Then we cannot go for directly. We need some simplification. For that what we have to do? Firstly our auxiliary equation is, that is m square plus 6m plus 8 equal to 0. Now wherever we factorize that term, then 4 2s are, then m plus 4m, 2m plus 8 equal to 0. First and second term has m common, then m plus 4, third and fourth term has 2 common, then m plus 4 equal to 0. Then it becomes m plus 4, m plus 2 equal to 0. Then m is equal to minus 2 and minus 4. Here case 1 factors are real and distinct. Then yc of s equal to c1 e raised to minus 2x plus c2 e raised to minus 4x. Then now move to the finding the particular integral. Yp of x equal to 1 upon f of d into q of x. Substituting this value 1 upon f of d, that is d square plus 6d plus 8 into cos square x. See here we cannot go for directly. Then for that, with the help of trigonometric formula, we have the formula cos square x equal to 1 plus cos 2x by 2. Then 1, we here apply this formula, 1 plus cos 2x by 2, and simplify that term, means according to the properties of linearity, or just give the simplification or individual term, then it becomes 1 upon d square plus 6d plus 8 e raised to 0x. Here 1 and common out 1 by 2 plus 1 by 2 1 upon d square plus 6d plus 8 into cos 2x. See here, 1 by 2 which is common out, see, then 1 upon d square plus 6d plus 8 into 1 as a e raised to 0x, and again 1 by 2 which is common out, 1 upon d square plus 6d plus 8 into cos 2x. Now here we apply the case 1, here we apply the case 2. Now simplified that term, means at that case we use the case 1, here values of a equal to 0, here values of a is equal to 2, here we use case 2, that is replace d square is equal to minus a square, here we apply case 1, then d equal to a. Now here first case we replace d as a 0, then 0 plus 8 e raised to 0, that is 1 plus 1 by 2 kept as it is. Here we replace d square as a minus a square, then minus 4 plus 6d kept as it is plus 8 into cos 2x. Then first term becomes 8 into 2, then 1 by 16 plus 1 by 2 kept as it is. Here it becomes 6d plus 4 into cos 2x. At that case 2 will be common out, then it becomes 1 by 4, here 3d plus 2. Now here we require the d square term. For that what we have to do? Taking conjugate, for that multiply and divide with 3d minus 2, means here in denominator portion a plus b, a minus b, then it becomes a square minus b square, then 9d square minus 4 into cos 2x. Then again apply case 2, then 1 by 16 kept as it is, 1 by 4, 3d minus 2 kept as it is, here d square is equal to minus a square, then it becomes minus 4 into cos 2x. See, 1 by 16 plus 1 by 4, 3d minus 2 kept as it is, 9 4s are 36, minus 4, that is minus 40 into cos 2x. Now simplified that term, then 1 by 16 minus sign common, then 4 4s are 16, then 1 minus 1 upon 163. Here in product form as a d, then it can be written as a d by dx of cos 2x minus twice cos 2x. Now 1 by 16 minus 1 by 60, 160, 3, derivative of cos, that is obviously minus sine 2x into 2 minus 2 cos 2x. Here minus sign will be common out and 2 also will be common out. Then 1 by 16 minus minus plus, because minus sign common out, 2 8s are 216, then 80, 1 upon 80, 3 sine 2x plus 2 cos 2x. That is our yp of x. Now general solution is a nothing but the combination of yp of x plus yc of x. Just substituting the values of equation number 1 and equation number 2, which is our general solution, where c1 and c2 are arbitrary constant. See, homework, same example you can ask in university example, like is a here sin square x. Then sin square x means what we have to do? We cannot solve it directly. For that, with the help of trigonometric function, we apply 1 minus cos 2x by 2. Suppose here we have the function sin 2x into cos 3x. Then what we have to do? We cannot apply as a product form. Then we have the formula 2cs equal to s minus s, or 2sc equal to s plus s. Then according to that formula, we can simplify that term and just finding the yc and yp. You can try yourself. Here dq plus 27 of y is equal to this term. This both the example as a homework, as a tutorial. I hope you guys learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do the share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel. And whenever I upload the new video, you get the notification. If you have any query, any doubts regarding this, then feel free contact me. Thank you so much for watching me.